these could be like this. So yesterday, don't write any of this, you're just paying attention so that you understand what the heck I'm saying. So yesterday, if I gave you something like this, which is a quadratic, it is a function, because for every x, there's only one y. For every input, there's only one output. And how can we check for something if it is a function? Do you remember? It's called a something line test. Remember? Rhymes with vertical. Starts with a V. Vertical line test. Yes, the vertical. Don't know why vertical is where I went with that, but that's okay. It's the vertical line test. So if for every x there's only one y, if you draw vertical lines and it only crosses once, then it is a function, because for every x there'll only be one y. So if I went here, you were taught this in grade 10. So if I draw a vertical line, it passes through once. So this would be a function, right? We're just reviewing what we learned in grade 10. So that would be a function. Now, would this be a function, though? Would that be a function? If I draw a vertical line, will it pass in one spot? For those of you saying yes, I don't know how. If I draw a vertical line, will it pass in only one spot? No, it passes in two. The moment it passes in more than one spot, it's not a function. So if I take a quadratic and I actually do the inverse of it, I get a sideways parabola. We saw that yesterday, didn't we? This sideways parabola is not a function, is it? Because it's going to cross through it in two spots, isn't it? And the moment the vertical line crosses through it in two spots, it's out. It's not a function. So what could I get rid of so that it would be a function on that second graph? What could I get rid of and then it would be a function? There's two arms on it. What could I do? Get rid of one of them, right? So if I keep just the top arm, would it be a function? Yeah. If I kept just the bottom arm, would it be a function? Yeah. So I need to keep one of the arms, and then it would be a function, correct? Mm-hmm. Now I know that this is 5, 0, so it'd be 0, 5, and it would do something like this, right? The reciprocal, or the, went to grade 11 for a second there. The inverse of it would be like a sideways parabola, correct? It would be something like that. So would its inverse be a function? The quadratic is a function, but would its inverse be a function? No, because if I drew a vertical line in this inverse graph, what would happen? 1, 2. We agree? So this is the key thing you need to know. We have to restrict the original function. We have to restrict the original. We never restrict the inverse. We restrict the original so that when we get rid of part of it, the inverse is a function. You told me that if I kept this arm or I kept this arm, it would be a function. We agree? If I kept one arm or I kept the other arm, it would be a function. Yes? So I always restrict the original, not the inverse. So if this was my original, and this is at 5, and I have to restrict the domain so that the inverse is a function, I need to get rid of half that graph, don't I? If I say, okay, if I make the x greater than or equal to 5, will my inverse be a function? Yeah, because if I made my x greater than or equal to 5, the only part of this graph I would keep would be this arm, correct? And then when I draw that, I'd have one arm and it would pass, wouldn't it? What's another option I could give instead of saying x is greater than or equal to 5? I could say x is less than or equal to 5. Then I would keep this arm, which would draw only one arm, still would pass. We agree? So in the curriculum it says I have to get you guys to restrict domains of originals so that when you draw the inverse, it actually is a function. So I can only pick functions that are going to cause problems when they're an inverse, right? So quadratics, when they're drawn as an inverse sideways, are not a function. So that would fit in here. Absolute value graphs, you did these in grade 11. Absolute value graphs are the ones that look like these. It would be like this. If I drew that sideways, it would still have two arms, wouldn't it? And then it wouldn't be a function either, would it? but say this is -3. How can I restrict the original domain so that the inverse would be a function? Well, I could say, okay, well, x has to be less than or equal to -3, or I could say x is greater than or equal to -3, and I would keep this arm or this arm, correct? And then when I draw it, it passes. What you guys try and do is restrict the inverse. I don't need the inverse restricted. I need to restrict the original right off the bat so that when I draw it as an inverse, it passes. Okay, what's the catch with inverses? X's become y's and y's become x's, correct? And I told you a lot of the time with inverses, you don't actually have to draw the inverse to answer the questions, do you? So if I want an x-intercept on the inverse, I just need to find the y-intercept on the original, correct? If I want the y-intercept on the inverse, I just need to find the x-intercept on the original. If I want the domain of the inverse, I need the range of the original. The range of the inverse, I need the domain, correct? So is there a way I can check and see if something passes a horizontal line test on the inverse? If I have just the original? So if I have the original and say it's like this, and I want to know if its inverse will pass. So I can do my plain old vertical line test on here and say, yes, the original is a function. We agree? But how can I check from the original if the inverse will be a function? Instead of doing a vertical line test, what should I do? Horizontal. Because all of these lines, vertical lines or x equals lines, are going to now become y equals lines on your inverse, correct? So if I want to check if its inverse is going to pass, I do a horizontal line test on the original. Did it pass? No. So is the original a function? Yes. But will the inverse be a function? No, because it does not pass the horizontal line test. So if you are just going off the original, if the original does not pass the horizontal line test, your inverse is not a function. If you draw your inverse, how can you check if it's a function? If you draw your inverse, you'll go back to doing vertical line tests, right? The horizontal line test only checks if the inverse is a function on the original. You don't do horizontal lines on the inverse. If you drew the inverse, you'd go back to doing vertical lines again. Okay? Kind of make sense? Okay. So we're going to look at this whole question. So here it says, given f of x equals x squared plus 1. What are the transformations on this? If I drew the original graph of f of x equals x squared, what's happened to my graph? We're on example 5. What's happened to my graph? I have a plus 1 at the back. What transformation is that? Vertical translation up 1, right? Could I just plug x squared plus 1 into my calculator, go to my table of values, and get my information off of it to graph it? Yeah. Or I can use the information, hey, I know how to draw an x squared graph. I now need to just take the x squared graph and move it up 1. So x squared is normally at 0, 0. It's now going to be at 0, 1. The next one's normally at 1, 1. It's now going to be at 1, 2. Normally it's at 2, 4. It's now going to be at 2, 5. Negative 1 is going to be here. Negative 2 is going to be at 5. And I always have to label. So this y scale, I'm making it P1 currently. And I didn't want to make it be anything else because I screwed up too much when I changed. X scale 1. You have to tell what your scales are. Or else you have to literally go 1, 2, 3 and number the whole graph. Which sucks. So this is the graph of y equals x squared plus 1. Can you tell me, does this one pass? Is this one a function? Is x squared plus 1 a function? Yeah, how do you know? You can draw a bajillion vertical lines there, and they're going to cross the graph each time once, right? No matter how many. Now, some people are like, what if, and this doesn't happen in here, but they do ask it in grade 10. What if you have something like this, and it passes, it passes, it passes, it doesn't pass. Then it's not a function. It doesn't matter if at one point in time it doesn't pass, it's instantly not a function. It doesn't have to not pass the whole time. It has to pass the whole time to be a function, and if at one point it doesn't, it's not a function. Okay? So this one would be, it would pass the vertical line test, it would be a function. Can you tell me how I would check and see if my inverse is a function? Draw a horizontal line through it. So I draw a horizontal line through it, and what happens? It doesn't pass. So the original doesn't pass the horizontal line test, so what can you tell me about the inverse? It's not a function. Okay, let's go answer some of the questions it says. Go back, take away dotted lines. Okay, so here, we want the equation of a reflection in the line y equals x. What the heck are they asking me to find? an equation of a reflection in the line y equals x. They're asking me to find what reflects in the line y equals x? Inverse. They're asking me to find the inverse. How do I find an equation of an inverse? What are my steps? Step 1, swap x and y. Step 2, isolate y. Done. That's it. There's 2 steps. That's all there is. 1, swap x's and y's. 2, get y by itself. Done. Okay? So we're going to swap our x's and y's. So we're going to get x equals y squared plus 1. Step 1 done. Step 2, get y by itself. So when I'm trying to isolate anything, which means I'm trying to solve for that variable, I always do reverse BEDMAS. So what do I have to move? What do I have to move first? Reverse BEDMAS. The squared or the plus 1? The plus 1. I need to do my additions and subtractions first. Whenever you're solving or isolating a variable, you do reverse BEDMAS. So I'm going to subtract 1. X minus 1 equals y squared. And now I can deal with the exponent. How do I get rid of a squared? And whenever I square root, I need to use plus or minus. So I get y equals plus or minus root x minus 1. And that's what gets me both parts, right? The plus root x minus 1 gets me the top half. The minus root x minus 1 gets me the bottom half, which we're going to actually lead into radicals today. So we're kind of just sliding from this into radicals. Okay. Do I actually need that equation to graph the reciprocal? And by reciprocal, I mean get out of 20S1, inverse. No. We can just take the coordinates from here and do what with them? Flip them, redraw. We agree? And then we can see if we get the same thing. So I currently have negative 2, 5. I'm now going to have 5 and negative 2. Then I have negative 1 and 2, so I'm going to have 2 and negative 1. And then I have 0, 1. Now I have 1, 0. And then 1, 2, 2, 1. And then 2, 5, 5, 2. Does it look correct? How can I check? What is it reflecting on? Line y equals x. I can sketch that. I can just throw that in there. I'm going to use this yellow. I'm going to use the pink. 0, 0, 1, 1, 2, 2, 3, 3. Ooh, getting curvy. Does it look like it's mirroring on there? Yeah. Is the inverse a function? How can I check? What kind? So if I'm checking on the inverse, I draw a vertical line. Does it pass it? No. If I want to know if the inverse is a function on the original, what would I draw? I would draw a horizontal line. Does it pass it? No. So if I want to check if the inverse is a function on the original, I draw a horizontal line. If I want to find out if the inverse is a function from the inverse, I draw a vertical through it. Okay? So we're going to go down to the bottom. We're going to write that down. Whoa. Whoa. Stop. So inverse function test. So if you're checking on the original graph, shh. Draw a horizontal line. If you're checking on the inverse, you draw a you're checking on the inverse, what do you draw?
If you're checking on the inverse.
To see if it's a function.
Vertical line.
Yeah.
No. I just want to sit over for it.
Okay? Yeah.
I'm kind of confused as to what you mean by that, like if it goes.
So if you're looking at the original graph and you want to know if the inverse is a function without having to draw it, you check and do a horizontal line test. If the original doesn't pass the horizontal line test, your inverse isn't a function.
How would it pass the horizontal lines?
So when you draw a horizontal line, does it cross more than once?
Oh, okay.
So if it crosses more than once, it doesn't pass it, then the inverse isn't a function. If it does pass it, like so look, if I look, say this was my original. Say my original was just a line like this. Would its inverse be a function? So this is the original. And I wanted to know if the inverse was a function, what would I have to draw? Horizontal lines. Does it pass them? How many times does each one of these cross? One. So does it pass the horizontal line test?
Yes.
Yes, so would the inverse be a function?
Yes.
Yes. If it crosses more than once with each line, it doesn't pass. So like this passes. If I draw a parabola, and I draw horizontal, say that's the original now, and I draw horizontal lines on it, does it pass? No. It crosses more than once on each line. So it doesn't pass it, so the original, or so the inverse wouldn't be a function.
What if you had like a degree 3 with a multiplicity?
Like this. If I drew horizontal lines, it would still cross once. So its inverse would be a function. Only with a multiplicity 3. If it was like this, though, would that be? This would be a function.
Yeah.
Would its inverse? No. Its inverse wouldn't. Yeah, you're right. Even though it passes here perfectly fine once,
Yeah.
here it's, so it's that.
So when it is multiplicity 3, the inverse is
Multiplicity 3 means that you have 3x intercepts in the same spot. You're saying degree 3 is, I think, what you meant.
But yeah, but if it was a degree 3 with a
Yeah.
multiplicity 3, like the inverse would be.
Yes. I get what you're saying. Yeah. Yeah. Yeah.
Yeah.
All right. So, side page. I'm going to give you 4 graphs. They're all original graphs. You are going to tell me what?
Passes or if it doesn't?
If it passes or if it doesn't. So I want to know if the original is a function, and then I want to know if its inverse would be a function. So these are all going to be original graphs. I want to know if the original is a function, and then I want to know if the inverse would be a function. Make sense?
Or we just like answer it?
I don't really care. It's your notes. You do what you want. So, yeah. Do what you will. These are going to be original graphs. You're going to tell me if the original is a function, and if the inverse is a function. I said 4. 2, 3. So I want to know if the original is a function. These are all original graphs. And then without drawing the inverse, I want to know if the inverse would be a function. I don't want you sketching the inverse. You could, but I don't want you to. I just want you to know quickly if it's an inverse or not. All the original first. So we're going to check if the original is a function. Is the original a function on this one? If I draw vertical lines through it, does it cross ever twice?
No.
No. So original function. What about this one? If I draw vertical lines through it, does it ever cross more than once?
No.
No. So the original is a function. What about this one? This is a log function. You don't even know what it is yet, but it's a log function. If I draw vertical lines through it, it passes. What about this one? Draw vertical lines all through it. It's a function. It's a linear function. Now, without drawing the inverse, which would take me a lot longer if I had to draw the inverse, because I have to pull points off of all of this and then flip the points to x and y's and then redraw, correct? How can I check quickly if the inverse is a function? Yeah. Now we do horizontal lines, because horizontal lines are y equals lines. And what are they going to be on the inverse? X equals lines, which are verticals, correct? So that's why we're using horizontals on the original, because they would be verticals on the inverse. So even though this is a horizontal on the original, remember, this black graph would flip sideways. I'd have a sideways V now. And what would this green one be? It would be vertical instead of horizontal, correct? This V is going to turn sideways like this, and that straight line is going to turn vertical. It's going to turn up. So that's why you check a horizontal on the original, because this is going to flip, and that is going to turn vertical on the inverse. So did it pass? No. So inverse, not a function. What about this one? Well, that's 2. Well, here's 2. Here's 4. It's really bad. What is this one going to be? Okay, what about this one? Did it pass? Yeah. So my inverse is a function. What about this one? Did it ever cross more than once? No. Now, before we go back, you're going to help me here. You're going to help me restrict the domains of the two that would cause inverses not to be a function. Like, this is not going to be a function because it's going to cross 2 spots, correct? This isn't going to be a function because it either crosses in 2 or 3 or 4, like a whole bunch, right? This is good. Check. Don't worry about it. This is good. Yeah, don't worry about it. We're going to look at those first 2 that the inverses would not be a function, correct? Right, Liam? Totally. So we're going to check and see what could I restrict the domain of those graphs that if I drew a horizontal line, it would pass them. Because I want the inverse to be a function if I restrict the domain of the original. So I want to restrict the domain of this black graph so that when I draw a horizontal line, it crosses once. Because I want the inverse to be a function. So what you would ask me is, hey, what the heck is this? We'll call it 4. So what could you tell me? Yeah. Greater than or equal to 4? Or less than or equal to 4 would give me the largest amount of graph that could stay, correct? But I could do any other varying of it. I don't have to just use 4. Could I use 6? Could I say x is greater than or equal to 6? And then I would just get this arm? And then would that pass? Yeah. What if I said less than or equal to 6, though? Less than or equal to 6 would be a problem, because less than or equal to 6 would give me this. And what would happen here? Yeah, be a 2. So you can't pick some of those, right? What could I do here? Well, you'd have to ask me where the arms end. So like say I give you like a 3 here and say a negative 4 here. Well, I could say x is less than or equal to negative 4. Then it would pass, correct? I'd only have this piece of the graph left. Or if I restricted it to x is greater than 3, then I would only have this part of the graph. And would that pass? Yeah. So you have to pick pieces that if I now only kept that piece, I could draw horizontal lines and it would pass. We agree? Okay. Let's go back to this question again. So I want you, we're going to skip B, I don't really care about P. I want you to restrict the domain of the original. So we have here y equals x squared. It shifted. No. Okay, this is going to be ridiculous, but it's the only way I can get it to go back. Seriously, no. I'm going forwards now. This is the problem. How dumb is that? Okay, we're back. All right, so I have the graph of y equals x squared plus 1 sitting over here, this blue one, right? If I draw a horizontal line, you guys told me, ain't happening. It's not passing a horizontal line test, which means my inverse is not a function. Which, well, we drew our inverse. Did it pass it? No. What I want you to do is tell me what I could restrict the domain of the original. So here it says, describe how the domain of f of x, this is the original, could be restricted so the inverse is a function. So what could I restrict the domain of that blue graph? Right now the blue graph is XER, right? It's a parabola, it's XER. What could I restrict the domain of this blue graph so that when I draw that red line it crosses once? Yeah.
Get rid of one of the arms.
Get rid of one of the arms. So I'm going to keep this one. I want to keep this one. It looks like I'm getting rid of it, but I'm keeping it. I'm squiggling it in. It's staying for life. How could I keep this arm? What would I have to restrict the domain of that blue graph to be? Sean? Nope. Yeah. 0. So you pulled the y value, which on a test, because I'll give you one of these on a test. I will. It's going to happen. You're like, I wonder if she will. She just told you she is. She's not lying. People, if I put it symmetrical on the y-axis like I have, if I put it symmetrical on the y-axis, do you see that? You guys will give me the y value. Every time I mark this test, it happens every single time. So if I make it symmetrical on the y-axis, you'll say y has to be greater than or equal to 1. Or sorry, x has to be greater than or equal to 1 or negative 1. But really, that's my y. What is my x here? What is the cuttingness? What is the axis of symmetry, which we learned about in grade 11? It's x equals 0, right? When it's on the y-axis, your x value is actually 0. Will you agree? So if I want to restrict my domain so I keep that left side, I would say x is less than or equal to 0. X and L are the reals. Now on a test, what I would ask you to do is I'll ask you to restrict the domain of the original so that the inverse is a function and draw it. So not only do you have to restrict the domain correctly and draw the correct part, you have to draw the inverse that goes with it. Some people will draw the other arm for the inverse. It's just a disaster. So that's not good. So say I give you this. You can go to a separate sheet of paper. You can graph it on here even. I don't really care. We'll go here. You can use this graph that's down here. I'm going to give you y equals x plus 3 squared minus 2. Now what I want you to do here, because then you can use this actual graph. I just shifted it again. I'm so good at this. What I want you to do here is I want you to restrict the domain of the original so the inverse is a function draw the restricted original and inverse. So how I always start it is I use pencil. I sketch the entire parabola, restrict my domain, correct? And then erase what I'm not keeping, because I did it in pencil. And then resketch the new part of the inverse by using the points that are still there, right? Take those points and do what with them? Flip them, redraw. Okay? You're going to try that on this graph right here, on this example 6. Now, can everyone pick different restricted domains? Yeah? I could go x is greater than or equal to 4. No one would ever pick that, I bet you, for this one, but I could. I could go x is greater than or equal to 4, and then I would have to draw only that portion, and then draw the inverse of it. Okay? So you could all have different ones. So I'm going to come around and check. I'm going to check your specific one. And if you finish it in time, I'm going to give you a little bit of time to work on. I'm only giving you a couple questions per test. You only have like one question because it's just that you did most of the other ones yesterday. And then we're going to move on to radicals. So start going, and then I'm going to come around and check it. Because you're all going to possibly have different answers. Hopefully not. But you could. So while I'm coming around and checking them, you can work on that one question, but we're going to move on to radicals right away.